Okay, so yeah, so Unit B, we're starting into final. So we're learning about the analytical tools of economic analysis. So this goes into a little more detail than your textbook goes into, which is why I've provided an auxiliary chapter. There's no Canvas activity based on the chapter or anything like that, but it's formally the reading for this unit. So encourage you to take a look at that. But thinking about what's going to happen as we get out of this unit, then I would start reading chapter 2 of the textbook, which is it's actually posted online, so pretty easy to get. It's available for free from the library, and I've just gone ahead because it's just a crazy semester and also put a copy of it on Canvas. And so you can find that in anywhere where it says you to read chapter 2, then I think you can actually find it embedded into that read chapter 2 assignment or whatever it's formally called on Canvas. So what did we talk about last time? Last time we started to define sustainability and how it kind of relates to economics. So we mentioned that like the thing about sustainability and economics, they come together in these intertemporal trade-offs. So the fact that decisions today affect the decisions available of those tomorrow or in the future. So we're balancing human well-being in order to achieve social equity across generational timescales. That's really what sustainability is. It's not something that is specifically focused on, ecosystem or anything like that. It is, but sort of secondarily. So it is an anthropocentric perspective. How do we change our activities or choose our activities today to be able to maintain human activity in perpetuity? And so that, again, anthropocentric, you could take a different perspective, a more biocentric perspective. And you could say that we have to constrain human activity in order to specifically for things that are anything that could possibly cause biological harm, we could say that is a bad thing. So that would be a much more biocentric point of view, where it would not be about the welfare of humans, it'll be about the welfare of the planet. And the only way we can evaluate the welfare of the planet is by, say, just making sure that it never goes down. And so that would be a biocentric perspective as opposed to an anthropocentric perspective. And I bring this up because really it comes down to actually two different philosophical ways of thinking about kind of more, it comes down to moral philosophy. And in moral philosophy, there's a consequentialist perspective. And in the consequentialist perspective, the focus is on the ends and not the means. And so it's more of, what do we get out of this? How do we maintain these particular ends? The kind of biocentric approach that fell is more into what's referred to as deontological perspectives on moral philosophy, where it's about duty, where it's more about the means than the ends. So a biocentric approach is, regardless of what the outcome is, there are just a certain set of things that we do not do, or there's a certain set of outlawed behaviors. Whereas the consequentialist view is that although we're going to penalize certain things because we can't just do everything, but we are mainly focused on an outcome. And that outcome we want to focus on is to maintain human activity in perpetuity, as opposed to having human activity today lead to the inability of humans to sustain themselves tomorrow. So that's the perspective we take in this class, that consequentialist perspective. I'm not saying it is the right moral philosophy, but it's more of, I'm saying that if that the tools you'll learn in this class follow from taking that perspective. So if you were to take that perspective, this would be the argument you would make. And then in reality, of course, when we make real decisions, it's a blend of these things. And so the kind of contextual relativism is, as you assert your own self as a decision maker, you'll use all of these things together. In this class, again, I'm not saying this is the only way you can make decisions, but I'm saying in this class, this is how we learn to make decisions, through this consequentialist framework. And this consequentialist framework, we're specifically not just thinking about outcomes, but we are specifically thinking about something called utilitarianism, where we are viewing each individual as having some utility, and we are interested in maximizing some aggregate utility from all of those individuals together. And that's really where the economics for sustainability is how do we use quantitative tools to try to maximize the social welfare of a society measured in terms of this kind of utilitarian terms. So that's kind of where we're going here. And in utilitarianism, the first thing you have to ask is who has moral standing? And so there's Bentham was one sort of philosopher here who had a sentience criterion, said anything that is sentient we should focus on as having, should be incorporated into this, should have a utility function that we need to aggregate together. So it may not just be people that we're focusing on. We might be focusing on a subset of animals or all of animals, but maybe not plants or something like that. And so there is some moral standing that we have to agree upon in order to make these frameworks go. So we assert some moral standing, and then we ask, what are the individual outcomes of those withstanding? And so those that we care about, those are the moral standing ones. Any particular action, what are the benefits and costs to those in the class that have the moral standing? And then once we are able to assess that at the individual level, how do we aggregate all that together and sort of say, what is the social welfare? What is the, how do we, if we can sort of put a thermometer on each individual and say, how you doing? Then how do you put a thermometer in a whole group of people and aggregate those together? Knowing that some people's temperature might not be as represented in the group as others. So how do we figure out these weightings? And so this quote here, again from Bentham, it is the greatest happiness of the greatest number that is the measure of right and wrong. So from this perspective, that decisions we make will cause some people to decrease in their happiness. But Bentham suggests that if a couple people have to decrease in their happiness for a larger number of people to increase in their happiness, then we've moved in a good direction. Again, I'm not saying that's the right way to do things or not, but I'm just saying this is a type of thinking that we are investigating using these economic tools. And that falls under utilitarianism. So are there any questions about these basic ideas? So that's like the limits of our moral philosophy before we start getting into kind of the quantitative stuff. I mean, you can ask questions now. Again, there's this URL here and this QR code that if you want to ask a question anytime in the class, but you don't want to attach your name to it, you can feel free to visit this and post an anonymous question. I've got a console that I'm monitoring there. If I don't get a chance to answer the question during the class, I'll do my best to post an answer in the discussion after.
I got a quick question.
So, yes.
I'm not sure if I caught that because I was jotting down notes, but did you say that like the utilitarian I can't pronounce it, utilitarianism, do they coexist with sustainability and biocentrism?
Well, so what I was saying is that the economics of sustainability, so taking these quantitative approaches to thinking about sustainability, is a subset. It fits within the model of utilitarianism. And utilitarianism is a type of what we call consequentialism. And those are different than the biocentrism. Biocentrism is a deontological approach where it says, regardless of what the outcomes are, we will never cut down this tree. We will never pollute the air. We're not worried about, economists are worried about how much can we pollute the air, given that we know that in order for us to do any human activity, there's going to be some pollution in the air. A biocentric approach would be to say all pollution is bad, just we have a duty not to pollute at all. Does that make sense?
Yeah.
And again, I'm not trying to say one is right and the other is wrong. I'm just saying that we have to develop tools in order to think about these things. And we are going to develop the tools that fit within the consequentialist and utilitarian frameworks in this class. And then as you move on and expand your thinking in other classes and then in your careers, then you'll blend the things you learn in this class with other things in order to make informed decisions. Part deontological, part consequentialist, maybe based on your context. All right. So let's skip the attendance exercise for now. And there'll be some other ones coming up later. So in today's class, we are focused on that part of that thermometer for the individual. How do we measure the individual outcomes? So we've come up with some individuals that have moral standing. Let's call them, they're just the people, the citizens of a country, for example, or maybe the people that live within a country, something like that. And we want to focus on one of them and say, how do we build up quantitative frameworks, so measurable frameworks that allow us to sort of say, what do you prefer? How happy are you? Those sorts of things. And so individual level outcomes that then later we'll figure out how to aggregate when we are thinking about, well, what's best for the group as a whole. So we are going to borrow from rational choice theory, and this fits within, for those of you who have an economics background or taken some economics, fits squarely within consumer choice theory. So how do people make choices? And so we are going to have to build this framework from a set of basic axioms that we assume are true about human decision making. So these might not be true. These are the things that you can attack, but hopefully we will come up with a simple set of axioms that are pretty easy to defend. And the axiom that, first axiom that we're going to build up here is the assumption of consistent preferences. And this consistent preferences says if a person prefers a banana over an apple, so that's this little like kind of greater than looking sign here, then we assume that they will continue to prefer a banana over an apple. So if we've gauged their preference, if we come back and ask them for their preference again, then they will have consistent preferences. Now, of course, you can imagine cases where it would be predictable, where people maybe don't have consistent preferences, maybe their context change and so on and so forth. And then you can use those contexts to evaluate how that changes our reasoning. But if we can assume consistent preferences, then all of what follows will follow naturally. The other assumption we're going to make is transitive preferences. If someone prefers a banana over an apple, and they prefer an apple over an orange, then we're going to assume that they're going to prefer the banana over the orange. So they'll prefer the banana over the apple and the apple over the orange, and it forms this line here. Those are the two axioms that we are going to build our theory of how people make choices out of. Okay, so any questions about those two axioms? Does that make sense right now? So pretty basic, not making wild assumptions about behavior or about choice. So then once we've got those, then we can start asking a question, what is in a decision? And I'm going to use fruit as this running example here because they end up working well, but we hopefully can generalize this to any sort of decision. So what is in a fruit decision? Well, we can think of that foods are bundles of nutrients, and the value of each food we can think of as being derived from the nutrients they consist of. This is just an assumption for this example. So as an example, bananas and apples both have potassium and fiber in them. Now I might be able to go to a physiologist, and that physiologist might be able to tell me that based on the amount of potassium in my system, there's a particular health indicator. If I have low potassium, then maybe it's bad for my health. If I have high potassium, maybe it's better for my health, but maybe how much better falls off over time. And so maybe there might even be too much potassium at some level, or it becomes toxic. But for now, we're just focusing on these where more potassium means better health, but maybe the amount of better health changes as I get more and more of this potassium. Likewise, fiber. It might be the case that if I have very low fiber, it's very bad for my health. And then if I get a little bit of fiber, I get rapid increases in my health scores. But then eventually I hit a point where I get enough fiber, and it might still be better to get fiber, but how much it adds to my health kind of falls off over time. So there are these two ways that if I were to ask a physiologist, ask a doctor, if I go for my annual physical and they take blood work, they measure these things and they can say, for the individual levels nutrients that are in foods, here's how you benefit. And so we are going to refer to these nutrients that are a part of the foods, not the foods themselves, the nutrients themselves, as goods. We refer to them as goods because as you get more of them, you increase the value to the person that we're focusing on. So it increases the utility of that. So when you get this relationship where more means better, it's called a good. If it's the opposite relationship, like pollution, where more means worse, it's called a bad. So it sounds a little funny, but we actually refer to things in plural as bads. So the nutrients that I'm focusing on today, they're a group of goods, but a bunch of pollutants together, each one of them is a bad, and together we might refer to them as bads, because as you get more pollution, it's always worse. Now, there's going to be some things where it's more complicated than that. Like I mentioned, you can have, once you get too much potassium, it maybe stops being good. And then so maybe we can't really call it a good there. But over the range that we're looking at, an increase in one gives you an increase in the benefit on the other. The other assumption we're going to make is the so-called ceteris paribus assumption. So this is Latin basically for other things equal. You're going to tell me that when you choose between a banana and an apple, you don't only worry, well, you may not mentally worry about potassium and fiber. You also worry about, sugar and how much it tastes and all these other things. And those are all important, and we will eventually need to add all those details in later. But for now, for the purpose of a simple analysis, it's easiest for us to boil things down to focusing on a limited number of goods at a time, and then hold all other goods as being constant. So in the case of fruit, there might be some other nutrient that, yeah, if they differed in that nutrient, it would change how we assess the fruit. But we are going to sort of make an assumption, it might be a bad assumption, that all the other nutrients are the same across the choices we're looking at. And we're making our choices only based on these two nutrients, let's say potassium and fiber, that they differ in. So that's what ceteris paribus means. The things that we're focusing on are the only things that differ in the choices. Anything that we're not focusing on, we're assuming to be equal across the choices. All other things equal. All right, so the problem now is that if we have fruit that differs along two dimensions, how do we make decisions among those pieces of fruit? So which utility function do we use? Do we make the decision just based on potassium, or do we make it based on fiber? Or is there some way we can combine these two together? What do we view as going on in the kind of head of the decision maker? And so what I'm going to introduce here is something that is called Pareto optimality. So at this point, I'm assuming, as a curiosity, just make sure everybody's awake, maybe in the participants list, so that's relatively anonymous, can those of you use the yes and no buttons at the bottom of your participants list to tell me how many people have heard about Pareto optimality or Pareto efficiency in any of your other classes? My guess is most people are going to say no. There's a handful of yeses. All right, that's very interesting. Great, okay. Yeah, so this is typically where this concept is introduced. I find Pareto optimality to be an extremely useful concept that is not kind of well understood among a lot of people, but it's a great way to bring these like multiple objectives into play. And so how does Pareto optimality work? Because then rather than thinking about a single objective so like in a single objective, we can say that, well, in the case of nutrient A, it's always better to have as much as possible because that's where the peak of this is. And nutrient B, the peak is over here. So it's always kind of obvious where the best is because if there's only one objective, you just find the peak of that objective. When there's multiple objectives that might have their peaks in different places, it's not quite clear what's the right option to choose. So let's say I consider 3 fruits, and each fruit is a bundle of multiple nutrients. So we're saying that fiber and potassium are goods, and that's because they're goods, it's because more fiber is better and more potassium is better. And the fruits are, and this is an economic term, are bundles of goods. So these are consumer bundles of goods. You don't just buy one good, you buy a bundle of goods. When it's rare that you buy, like the cable companies don't want you to buy just cable or just internet. They want you to buy a bundle of these things together. And they might force you to buy a bundle of these things together. Just like nature, it's hard to buy just potassium or just fiber. You got to buy them both together. And so all 3 of these things, the orange, the apple, the banana, have both of these nutrients, fiber and potassium. One fruit, multiple nutrients. That's what we mean by a bundle of goods. Now the orange bundle down here, it has less potassium and less fiber than both the apple and the banana. And so we refer to the orange bundle as being dominated by either of the other two fruits, because the apple is better in both dimensions and the banana is better in both dimensions. So that's this term domination. Domination means that if something dominates another, then that means that it is better in all dimensions of interest than the other thing. And so the other way to look at this is that you would never, if all you cared about was potassium and fiber, you would never eat an orange. It would be dumb to eat an orange if you have an apple and a banana available, because there's no reason you have to eat that orange, because you can eat a banana and it'll be better in both. But you could also eat an apple and it'd be better in both. So the real choice is between the apple and the banana. Changing from a bundle to another where you've improved in all dimensions is what we call a Pareto improvement. So if my strategy was to eat an orange and I switched my strategy to eat a banana, I'm now doing better in both of my goods, both potassium and fiber. And so that was an improvement. There is no way I can criticize that change, because it's just better. If you're saying all you care about is potassium and fiber, why are you eating an orange? I don't care what other one, just eat something else. Eat a banana or eat an apple. That's it. Either one would be a so-called Pareto improvement. Now, from the banana, if all I have are those three fruits available, there are no other ways I can improve upon the banana. And so I view the banana as being Pareto efficient. It's efficient because I cannot make a Pareto movement away from the banana. There are no choices up here that are better in both simultaneously, potassium and fiber. If I wanted more fiber, I can choose the apple, but that requires me to lose out on potassium. So I can choose the apple, but that's not a Pareto improvement. So because there are no Pareto improvements, this is what's called Pareto efficient. And so if we select all of the options that are Pareto efficient together, we have the so-called Pareto efficient set. And so these are all of the options from which, if you picked one of them, there would not be an obvious choice of something else to pick that would dominate that option. So this is where hard decisions are made. They're within the Pareto efficient set. So you never have a reason to eat the orange. So that's an easy decision. Just don't eat the orange. But you do have to decide, do I eat the banana or the apple? I have to give up potassium to gain fiber. So the Pareto efficient set represents a trade-off. So this is mathematically, and there's a question here, I'll answer that in a second. The Pareto efficient set is how we more mathematically capture the notion of a trade-off. If something is being traded off, that means that the two options at the beginning of the trade-off and the end of the trade-off are both in a Pareto efficient set. In order for you to move from one to the other, you had to give up on one good in order to get more of another good. There was a question, are Pareto movement and Pareto improvement interchangeable? Yes. Those are two terms that are just commonly used in literature. Can you make a Pareto movement, or can you make a Pareto improvement? Some people add the improvement just to make it clear that it's getting better, but movement is also fine. Any other questions about, in fact, I think my next slide is a question slide. Any other questions about these terms? Something that dominates another term, something else.
I got
Something
a question
that is a
again.
Yes.
Just making sure. So like the apple or the banana, if there are no other movements can be made for the Pareto movement, it's considered a Pareto efficient.
Yes, if you cannot make a Pareto improvement, then it is efficient because you've squeezed out all of the Pareto improvements. The Pareto improvements are the easy choices, and you've gotten rid of all the easy choices. So now you're at an efficient solution,
Okay.
Pareto efficient.
All right. Thank you.
Emily, I think I saw a hand up.
Yes. Okay. So I understand Pareto movements and Pareto efficient bundles based on the slides. Can you explain what Pareto optimality is again with relation to those two terms?
Right. Okay. So yeah. So an option that is Pareto optimal is basically Pareto optimality and Pareto efficient are effectively synonymous terms. So if you drill down into the literature, there is a slight difference between something, the Pareto efficient set, and something called a Pareto frontier. And so, but these are like technical differences. And so basically when we look at these things here, you can think of Pareto optimality as the optimality of a set. So my guess is all other notions of optimality that you've had up to this point is you're looking for the one solution. What is the one way to make what is the best way to do things? And a Pareto optimal approach says there may not be one best way to do things, but what we want to do is get rid of all the bad ways to do things. So something being Pareto optimal is something that you're guaranteeing that the option you choose might be one of many options, but none of those options are kind of trivially bad. They all represent trade-offs from one option to another. Does that make sense? So finding the Pareto optimum means finding the Pareto efficient set, as opposed to like in calculus in high school, finding the maximum value was taking the derivative and set it equal to 0 and solving for that. And I was finding the maximum value. We're not interested in the maximum anymore. Now we're interested in the set of things that are trade-offs. Because the orange, we want to exclude the orange. We don't even want people to be considering the orange. We want people to only be considering between an apple and a banana, because an orange is all bad.
Okay, thank you.
Mm-hmm. Any other questions? I know this is about fruit, but I hope you can put this in your mind, and we will as we move on in the class, into other types of goods, other types of things, other bundles of things. I make this choice and I get these multiple things out. And I really value the things I get out of that choice. And how I trade from one choice to another is really how I'm giving up different aspects of that bundle of things that I'm choosing from. If you're choosing a partner, for example, then this partner is really, really smart, but he's not very compassionate. This partner is extremely compassionate, but sometimes they're not very helpful when I need them to help me on difficult problems. So attractiveness and maybe a compassion and intelligence might be two goods that you put into a bundle. You can't get just one. If you can get an improvement in both, that's an improvement. So you got this loser over here and this other loser over here, and then there's this other person that's both compassionate and smart. Well, then of course, pick that person. But so that would be a Pareto improvement. But if that person doesn't exist, then you've got a trade-off, and you really have to ask yourself, do you want compassion or do you want intelligence? So it's not just about fruit. Any other questions? All right. All right. So let's do an attendance exercise for kicks here. And so I guess so here's the question. The question is, which I'll also type into the chat. So attendance question is, what is another name for Pareto movement? So this was already sort of asked by someone else in the class. So you can just visit this URL. You can either do it now, or you can wait 24 hours after class to visit this URL, or go to that QR code. Make sure you log in with your ASU ID into the resulting Google form. Put this in the top question 1, and then just leave it sit there, and we'll submit at the end. So there might be another attendance question as we go. So again, the question was, thank you, Jeremy, for posting the link in the chat. So there's a link in the chat as well. And so what is another name for Pareto movement? Just put that into question 1 and let it sit, and we'll hit submit at the end of class. Okay, any other questions before we move on to the adding in slightly more advanced concepts here? Okay. All right, so if we're thinking about this banana and apple example, if I draw a horizontal line out from the apple, anything above that line is better in fiber than both options, the apple and the banana, because we know the apple's got more fiber than the banana. So anything that has more fiber than the apple is going to have more fiber than the banana. Likewise, if I draw this vertical line out from the banana, anything to the right of that line is going to have more potassium than both. Oh, I'm sorry, I got there's a question. What happens if you don't get the question right? Attendance questions are graded for completion, not correctness. They're really a survey for me to see how well you guys are comprehending the lecture. It's a way for you to reflect upon it. So long as you give me a coherent answer, like if you gave me the answer of 3, well, it's clear that you were just randomly putting in an answer into the attendance form, and for all I know, you didn't come to class. So as long as it is a answer that makes sense for the question asked, you will get credit. They're graded for just completion, coherence, not for correctness. All right, so the green section here represents bundles, so food items, that potentially could dominate everything else. So we know that these are our Pareto-efficient set. They're Pareto-efficient because nothing dominates them. But if we were to introduce a potato, and by the way, I did look up nutrient numbers for all these when I came up with this. So a potato actually is higher in potassium and in fiber than in both of these. So if I could find a potato, then suddenly my hard choice between the banana and the apple goes away. This is just like finding the partner that is both compassionate and intelligent. Here, it's compassion only. Here, it's intelligence only. Suddenly, someone new moves into town. They're both compassionate and intelligent. That's the potato. And suddenly, you don't have to worry about making a choice anymore. You just pick the one that's got both of the things you like. So that would be the ideal, is to choose this potato. So the potato dominates the rest of them. So you should choose the potato if it is feasible to choose the potato. Now, in the case of fruit, what might make it not feasible? Like, let's say a potato was available at the store. What might make you not able to choose the potato? Anybody, either in the via audio or so there's questions. So the how to cook the potato is, yeah, okay, I'm seeing cost and price. So how to cook the potato is actually effectively kind of a cost of the potato. Like maybe you don't have the resources for it, but more fundamentally, somebody said, I saw cost and price. Julia said price, Ross said cost. Those are the types of answers that I'm looking for here. If I had an infinite budget, I would buy as many potatoes as I want. But it might be that I don't have an infinite budget. And so I might only have a certain number of dollars in my pocket. And so those dollars cannot buy me a potato. So now I need to ask myself, what can I buy? And we can draw this budget line, which separates the things that I can buy from the things that I can't. And so where does this budget line come from? Well, in the case of goods, if you think about fiber, let's say, or whatever this good is, we could put a price, and I will call that thing PF, the price of fiber down here. And so maybe I'll change this to a pen. So I've got my price of fiber, PF, right here. And then here, this is for fiber over here. And so if you think about it, for any amount of fiber, so let's say I have an amount of fiber F, the cost of buying pure fiber will be PF times F, because there's F units of fiber and each fiber unit costs PF. So that is the price of pure fiber over here. And then likewise, if I just bought pure potassium, so that would be like over here, pure potassium. If I knew a price of potassium, I'll call it PP, and I have my quantity of potassium P, which I'll put down here, P, then this would be the price of then this would be the cost in dollars of that pure potassium. And so, and we'll get into this in more detail as we work some examples moving forward. But for now, I hope you can at least see conceptually that in principle, if I came in with a certain fixed amount of dollars, I could use the prices of each goods to figure out the most potassium I could possibly buy and the most fiber I could possibly buy. And any mixture where I give up a little fiber to gain a little potassium or vice versa would fall on the line in between them. And so this line here that I've just drawn represents, if I know the cost of fiber and the cost of potassium, it represents every possible mixture of fiber and potassium I could buy for a given budget, for a given dollar amount. And anything below that line, I have enough money for. Anything above that line, I do not. And so what I've just drawn down here is just a reproduction of what I drew up here. If I had enough budget to buy both the apple and the banana, but not the potato, then effectively the potato is not feasible. I cannot select the potato. It is over my budget. I can only select the things that are under my budget line, and that includes the apple and the banana. This is assuming that we can price goods out individually. And in a lot of the goods, like a good might be electricity and water. You know, like I have a certain budget for utilities at my house, and there's a price of electricity and a price of water. And based on my budget for utilities, that tells me how much total electricity I could buy if I didn't use any water, how much total water I could buy if I didn't use any electricity, and what every possible mixture of water and electricity I could buy on that budget. That's all that we're kind of showing here. So we can draw a budget line which separates out choices I'd like to make from choices I can make. Okay. So we refer to this as a budget constraint line, and we refer to everything underneath it as a budget set. And so we can only choose things within our budget set. So we would like to choose Pareto optimal choices from within the set of choices in the budget set, which gets us back to choosing just between the banana and the apple. All right. Are there questions about this? Again, you'll start writing your own budget lines and drawing this sort of stuff in as we move forward. So we will get into more numerical examples. For now, I'm just setting up the framework so that we can kind of start thinking about motivating the math that is to come. How would this change with more goods? Excellent question, Madeline. Right now I only show 2 goods, but you could imagine that there would be additional goods that I could draw hanging off the edge here, so multiple dimensions. And the budget constraint line then becomes a budget constraint plane. And so you know from maybe algebra or geometry that the equation of a line has got basically an x and a y in it. Y equals mx plus b. There's x and a y. And so you get the equation of a line has got one independent variable x and a dependent variable y. We can, once you go to multiple goods, then you don't have a budget constraint line anymore. You have a budget constraint plane, because then you're going to have 2 degrees of freedom instead of 1 degree of freedom. And so when you only have 2, you basically say, once I choose my potassium, I know how much fiber I get. Once I have 3 things, then once I choose the 2, like I choose water and I choose electricity, well, that will fix the amount of cable I get. And so that becomes a plane of options. So it gets a little more geometrically hairy, but we can definitely generalize this whole thing to more than 2 goods. For simplicity, I'm just keeping it to 2 goods, but trust me in that the math generalizes quite naturally to multiple goods after that. Any other questions? All right. So if I reduce my budget slightly, so go back to this slide, the budget is up here, and I'm going to reduce the budget slightly, then what I might find for this particular budget, for this particular price of fiber and potassium, that both the apple and the banana fall on this same budget line. Now think about this for a second. Can someone tell me, what does that reveal about the price of the banana and the apple? The fact that they're on the same budget line. Any guesses?
Would that mean they're both the same? I mean, like the same, that cost the same? Like you can trade off for one for another? Exactly.
They're both the same price. That's right. And I'm getting that same answer. I see from Jessica and Julia, both say same price. That's right. If two things are on the same budget line, so if you lower a budget constraint line, you say, if I had $100, and I say, well, now I have 95. And if you notice the two of your choices, both fall on the $95 line, that means they're both $95. I can spend all of my money on one banana or all of my money on one apple. And that's it. After that, I have no money left over. So this kind of highlights, and this is, I think, the other answer we got here about choosing, one substituting for the other. Budgets introduce what we call opportunity cost. If I buy a banana, I'm not able to buy an apple because I don't have any money left. So it introduces a trade-off as well. So we have our preferential trade-offs. So there's just the physical trade-offs of, if I happen to choose an apple, I have to use less potassium to get fiber. But there's also trade-offs introduced by budget. So of all the choices that are available to me, I can only make one choice because I only have the budget to make one choice. And so that is what we refer to as an opportunity cost, which adds to the cost of these things here. It'd be one thing if you'd say, yeah, why don't, I picture that meme, why not both? Why don't I just buy both the apple and the banana? Well, the reason is because the budget forces you to buy one. So if we keep that in mind and we give a bunch of people this choice, we might notice that even though the apple and the banana are both the same price, out of 100 people, all 100 or maybe 99 of them choose the banana. Or maybe we give the same person the choice 100 times. And if they really were just substitutable options, then we would expect 50 times them to choose banana and 50 times them to choose an apple. But we might see that they still choose the banana overwhelmingly over the apple, even though they're the same price. So this goes to show that just knowing something's price isn't enough, that people are valuing things based on other factors that we need to model into here. So that exercise of forcing someone to make choices on a budget and then watching what choices they make is something that economists call revealed preference. I don't know what your preferences are. I could ask you what your preferences are, but instead of that, I'm going to send you into a grocery store with a budget, or I can maybe study data and be able to tell what people's budgets are. And based on that, then I'm going to see, of things that are the same price, which things are you choosing? And that is your revealed preference. And what revealed preference does for us is it allows us to build multi-attribute utility functions. So we could ask a physiologist about potassium. We could say, model the human body and tell me how potassium relates to health outcomes. And they might be able to look at the genes, they might be able to look at transcription machinery and all the things that go on to a cell, and they can tell me what potassium's for. And they can say, this is how potassium increases health outcomes. But when I actually ask a person how they're choosing among bundles of potassium and fiber, then I don't have a physiological basis for understanding the utility that people perceive. And so I have to ask them for that. And by seeing what bundles of goods they choose, it allows me to form a so-called multi-attribute utility function, where I'm not measuring the utility of potassium or fiber alone. I'm measuring the utility of different mixtures of potassium and fiber, and where I'm stuck with whatever mixtures come in the banana and whatever mixtures come in the apple. And so by seeing that they always choose the banana over the apple, then that gives me a hint that, so again, utility of a bundle of multiple goods, that gives me a hint that this particular person values potassium more than fiber. In other words, in order for them to tolerate reducing their potassium, they would need an increase in fiber that is even greater. So they would need a larger increase in fiber to substitute for the losses in potassium they got because of how important potassium is. And so that's what I've revealed. I gave you the same budget and you always chose the banana. That tells me that you value potassium over fiber because you could have gotten both. And really the only difference between these two is that one is higher in potassium and lower in fiber. And the other one's higher in fiber and lower in potassium, conversely. And so the fact that you're always choosing the banana tells me that you must value potassium more than fiber. So what I could continue to do with that person is I could then ask them, how much more fiber would I need to add to this banana, or sorry, to this apple to get you to pick it over the banana? And that, so right now, let's say the apple is here. If I added a little bit of fiber to the apple, so it has the same amount of potassium, but now it has just this little bit more fiber, like I've drawn here. If now that person goes to a 50-50 split, where sometimes they buy the apple and sometimes they buy the banana, if I can manage to keep the prices the same, then that would reveal that exactly how the person trades off fiber versus potassium. It would give me a way to quantify the relative value of fiber versus potassium. And I could draw a line, that's what this green line is, of all of the different artificial foods that I could potentially create that this person would be indifferent to choose if they had the money relative to a banana. And so this is a so-called indifference curve. An indifference curve is the set of all hypothetical bundles of goods that are equally preferred by a consumer. So the apple and the banana are not on the same indifference curve, and that's why they always choose the banana. But this hypothetical fiber-enriched apple has so much more fiber that now suddenly this person said, you know what, I'm willing to give up the potassium because I get so much more fiber for that apple. So the hypothetical apple that sits up here on the indifference curve, that hypothetical apple is in the indifference curve with the banana. Are there questions about that, what I mean by an indifference curve? This is a critical concept in economics, the indifference curve. And we're gonna just keep piling on here. So I wanna make sure everyone understands that this indifference curve is the hypothetical set of bundles, the hypothetical foods that are mixtures of potassium and fiber, that if you were to ask somebody without worrying about budget, if they would pick them, they would pick them equally as much as they would pick the banana. And that puts them on the same indifference curve. Questions? Super important concept. Okay. All right, so consumers prefer indifference curves that are higher. And by higher, I mean higher in this direction. So foods that are on the green indifference curve are always going to be preferred over foods that are on the gray indifference curve. So if all you had to choose one was from foods on the gray indifference curve, you would choose equally likely any food on the gray indifference curve. But if you were given a food also that was on the green indifference curve and a bunch on the gray indifference curve, you would always pick the food on the green indifference curve. And that makes sense because if you look at the gray indifference curve, this goes back to the Pareto dominance idea, is that these foods tend to be lower in both goods than foods that are up here. And so that's what we mean by you're giving up on both when you go from the green to the gray. That is a bad movement to make. But generally going from the gray to the green is a good movement to make. And so those are good movements to make, which is why we prefer them. This goes into the Pareto movement. You can make Pareto movements up in different curves. Okay. So I could keep adding indifference curves, and they can go lower and lower and lower. And with the more indifference curves I add, then I keep introducing foods that I would choose the foods on those higher indifference curves. And so it's always better to pick foods that are on the highest indifference curve that you can afford, that you can get to. And that reveals why the banana is so special here, because the banana represents the best indifference curve that money can buy. There is only one member of the green indifference curve that crosses into your budget set. Remember, your budget set is everything underneath this budget line. And there could be a bunch of other foods that are on the green indifference curve that you would pick equally as well as the banana if you could afford them. But the banana is the only one that you can afford. And you will choose that banana because it is the best indifference curve you can get to on your finite budget. That is how economists model consumer choice among multiple goods, is that you have indifference curves of options that are equally preferred, but they don't all cost the same. So you combine the indifference curves with the budget line, and usually at the points in which they kiss like this represents those bundles of goods that are the most utility for the cheapest price. And that's what the banana is. The most utility, the highest indifference curve for the lowest price. Are there questions about this depiction? Okay. So naturally, the potato, it's hanging out there. If I were to take my budget and increase it, then now the reason I choose the potato is it allows me to achieve a higher indifference curve within my feasible budget set. So if I had an infinite budget, I'd always choose the potato because it brings me to a higher indifference curve. There are a bunch of foods, potential foods, that if they could manage to synthesize a food, there would be a different mixture of fiber and potassium. If they were to trade off the fiber and the potassium in such a way that it landed on this indifference curve, I would pick those foods equally as likely as I'd pick that potato. But so long as I only have the potato, I would pick that potato more than any of the rest of these foods. Okay, so any questions? I'm going to look back at the anonymous questions here. All right. Does that make sense? Are the indifference curves hypothetically never ending, as with an infinite budget? Are there always more and more indifference curves? A good question. So that actually goes right well into properties of indifference curves. So that'll be answered here. So indifference curves, if these are goods on the axes, so they're not bad. So we're not talking about pollution here. We're talking about things that are goods. And remember, a good means more is better. If you've put something that's more is better on every axis, then all of these indifference curves will always have a downward slope. They'll always be kind of in this direction, downward sloping. And they'll never cross. I mean, that just makes sense. Something on an indifference curve is differentiated from something that's not on or something that's on a different indifference curve. So there's every indifference curve kind of is somehow got space between it and every other indifference curve. And then any level of utility is possible. So this, I think, answers the question here, is that the entire space of utility, so this entire space over here, is covered by indifference curves. So you can imagine indifference curves. Between every indifference curve, there's a bunch more indifference curves. Above these indifference curves, there's a bunch more indifference curves. Now, it doesn't mean that there are bundles of goods that exist that populate all of those, but it does mean that if you created a bundle anywhere, I could measure what indifference curve it was on. That's basically what it says. I can assign utility to any bundle you give me. That's basically what this is saying here. And then the shapes of these is what we're about to get into here. And so I'm listing this as a property, and this Y is more of a just motivating the next couple of slides here. But you'll notice that these indifference curves I've drawn here are all, we would say, not just downward sloping, but are convex to the origin. So they all bend in this particular way. They're not sort of just straight lines, or they don't look like this. They don't look like this. They're all, and they start looking more and more like that, but they're all basically convex to the origins. They have that downward bend to them. And that's because these goods have diminishing marginal utility. So as you get more potassium, it becomes less interesting to get even more potassium. And so that diminishing utility is what's going to be reflected here. And that's what we're about to talk about here. So I hope that answers your question. So before I move on, are there any other general questions about this idea of indifference curves and how we plot bundles on indifference curves? Okay. All right. So the what determines the convexity, the shape of these indifference curves? So if we go back to our individual good utilities, our single utilities, like how good is potassium alone and how good is fiber alone. Then again, these are the ceteris paribus, this idea of if I were to consider one of them at a time, then we can see that you can get these things where you have diminishing marginal utility. So a small increase in fiber when you have no fiber gives you a big increase in utility. But if you already got a lot of fiber, that same small increase in utility gives you, or same small increase in fiber gives you only a small increase in utility. So this one clearly has diminishing marginal returns. I'll just say DMR, diminishing marginal returns. But over here, at least initially, there's accelerating returns to fiber. So initially, you get a little bit of fiber and you get only a little benefit. But once you have some fiber, that same increase in fiber gives you a huge increase in benefit. Now, eventually, you get diminishing marginal returns out here. So you get the diminishing marginal returns later. But initially, you have accelerating marginal returns. So this is what we mean by diminishing returns, is that the same increase in quantity doesn't give you the same increase in utility. And so if we look back at our multi-utility or multi-good utility framework here, then we can look at the slopes of these curves, and we can say at any individual point, so at any individual good, we can say if you were to decrease the amount of fiber or amount of potassium, how much fiber would you need to add to stay on the curve? And so that tells us the slope of the tangent line at any individual good. So this line that I've drawn here represents, like, if you had whatever that was, an apple or anything like that, if I increased the amount of fiber by a small amount, then how much potassium would you be willing to give up? And that gives you the slope of the tangent line there. And we refer to this slope, and technically it's a negative slope, but we get rid of the negative and we refer to this slope. So instead of thinking of it as rise over run, you can think of it as like fall over run. So this is the fall here. So how much fiber am I giving up over how much potassium I'm gaining, or vice versa. And we call that the marginal rate of substitution, or MRS. And so, and then we might then say of one good for another. And so the of is the thing in the numerator and the for is the thing in the denominator. So you could multiply this by the thing in the denominator and you'd end up finding out how much the thing in the numerator you would get for the gaining or loss. So if I wanted to, if I said, all right, how much potassium, if you're willing to give up 1 gram of potassium, if I multiply 1 gram of potassium by this marginal rate of substitution, it'll tell you how much fiber you would need to gain in order to be willing to give up that 1 gram of potassium. So that's where that comes from. And so we then are interested in what is the slope of is it steep or is it shallow, this marginal rate of substitution. And that tells us our kind of relative importance of one good over the other, and how our how we value each good as we get more of each good. So just to give like an example of that, if I imagine a bundle down here that is very high in potassium but is very low in fiber, then what I see here is I've gotten a much shallower line here. And so my delta F over delta P is going to be a very low number. It'll be a low number. And so because it's a shallower line, and that means that we're willing to substitute less fiber for the same amount of potassium. So in that case, when we have lots of potassium but very little fiber, then what we're saying is that we value potassium less and we value fiber more, which kind of makes sense, is that when you have less of one thing and more of another, you probably are going to value the thing you have less of. Here, we have less fiber, and so we would need to give up a lot of potassium, or we are willing to give up a lot of potassium to get even a little bit of fiber. That's what this marginal rate of substitution is saying. It's a low number, which means we're willing to give up a lot of the thing in the denominator to get a little of the thing in the numerator. Now, I can flip that and consider a steep slope on the other side of it. On the steep side of it here, then that is saying that, that if this MRS is high, then that means that in order for me to give up a little potassium, I have to get a lot of fiber in return. And so that's what this steep slope is depicting here, is that suddenly I value potassium a lot more. So in this case here, I value potassium more and I value fiber less, which makes sense because I have more potassium, I have more fiber, so I don't really care about getting even more fiber, but I have less potassium. And so I care about the thing that I have less of. And so if you kind of do the math there and you think about these types of goods where when you have more of them, you don't want even more of them, when they have diminishing marginal returns, then it naturally is going to be the case that indifference curves are going to have this convex slope to them. They're going to be sloped down this way. So when both of your goods have got diminishing marginal returns, your indifference curves are always going to have this curve to them where they're pulled down towards the origin. They're convex to the origin, where the origin is this thing over here. All right, so that's what we're saying here. The convex to the origin implies diminishing marginal utility. So if we consider convex or concave, then that if you happen to see concave ones of these, then that's a little funnier because then it's like an accelerating returns where I get more of something and I want even more of it. So those are kind of weird, but as we start getting into thinking about bads instead of goods, then the shapes of these things will start changing, because it might be like with pollution, I can tolerate a little bit of pollution, but if I get a lot of pollution, then I really can't tolerate much more of it. So we'll see the shapes of these things get more interesting as we start considering bads as well as goods. But for now, we're just focusing on goods. All right. So we're getting towards the end here. So are there questions about this basic thing? So basically all we were setting up in this lecture is how do we come up with a framework that we potentially mathematically can think about how people make decisions when those decisions are based on multiple dimensions. In this case, potassium or fiber, but they could be based on a lot of different things. So any questions about this basic multi-utility framework? Or multi-good framework. Yes.
Can you elaborate on what you said again about like considering convex or concave again?
Yeah, so this is really just meant to be food for thought here. Is that if you see convex, then that just means that your goods have got diminishing marginal return. If instead you had this concave curve here, then a concave curve is a little funny because it's saying that when you get a lot of potassium here, then you suddenly are willing to give up more fiber for the same amount of potassium. So these are, concave curves would be kind of strange in terms of goods. It would take a weird type of nutrient in order for us to get these concave curves. So all I'm kind of trying to say here is that the convexity, I'm hoping it makes sense, that we wouldn't expect to see concavity for these types of goods. But we might expect to see funky things happening when we start considering goods and bads together, for example, or types of things that aren't goods, types of things that do have weird accelerations and decelerations and accelerations again. So in theory, you could have concave indifference curves, but in most of the examples we'll see, it'll be good versus good, and both will be diminishing marginal returns, which means they're always going to be convex, like the examples I've drawn.
Okay, thank you.
Any other questions?
Is there a special name for these graphs with the indifference curves and the budget constraint lines and the goods on the axes? Is there some sort of like title for these?
I don't have a name that I will refer to them as. I'm not saying that. It wouldn't surprise me if somewhere out there in social science, there is someone who has come up with a name for these. I mean, I just view them as I view each one of these indifference curves. Sometimes they're called level sets of the multi-objective utility function. So I guess I could type that in the chat, level sets of multi-objective utility function. And so the idea here is like, if there's all of the dimensions of things that I care about, if I were to have a function where I evaluate what mixtures I like better than others, I can form kind of a topographical map where the things that I pick above others are higher than the things that I don't pick. And in that topographical map, I could then sort of say that the heights in that topographical map are these indifference curves, are these so-called level sets. So this is really a topographical map of choice, but it just so happens that we are considering kind of simple geometries where things are always kind of going uphill. And the only thing that's keeping us from getting to the top of the hill is we just run out of energy, we run out of a budget, so we can't go up any higher. But you could imagine much more complicated utility spaces where there's peaks in the middle and troughs and so on. So level sets is a common term that's used instead of indifference curves. But I would just say people normally just call these indifference curves. Oh, I see some other questions here. So the steeper the curve, the curve, the more value we want. The more we want of it, we're sacrificing the other good for. So the question there was about the steepness of the curves. Excellent question. And so I mean, keep in mind that the steepness of the curve changes as you go down the curve. This curve is steep here, but it is shallow here. When you are at a steep portion, then that means that you are willing to give up more of the denominator to get the same amount of the numerator. Let me see if I've said that right. It's probably easier just to visualize here. When you're at the steeper portion here, what it's saying is that if you give up a little bit of the denominator, you have to compensate that with a lot of the numerator. So in the fiber case, if I already have a lot of fiber, if I give up some of the thing I don't have much of, potassium, the only way I'm willing to do that is to get a lot of fiber. And so that's why it's steep. It's depicting that fiber is more important to me. If I give up a little potassium, I have to get a lot of fiber. If it's shallow down here, then then it depends, then it's the other way around. So when it's shallow, then that means that I am willing to, because I have less fiber, then if I give up a little fiber, you have to compensate with a lot of potassium, because I already have a lot of potassium, so the only way I'm willing to accept more potassium for giving up a little of the thing that I don't have is if you give me a lot more potassium. So that's what it's, the steepness tells me what my relative valuation of the two goods are based on how many of the goods I already have. So you pick a point that tells me how many goods I have, and the steepness tells me the relative value of the two goods that I have. And then I see another question, would it also be fair to call this a consumption possibility frontier, although dimensions are arguably a bit different? So we will get into this, to these ideas as we get a little bit farther. I don't want to get into this ideas about consumption possibilities, because it gets kind of closer to what we were talking about with like budgets. And so we already said that, well, if I draw a budget constraint line across here, that, you know, that basically means I only can consider curves underneath the budget line. And so the somehow the budget line is kind of a possibility frontier. And we will, in the future, when we start talking about time discounting and things like that, figure out a way in which we turn budgets into something that's more akin to this question that was asked in the chat about possibility frontiers. And so we'll get into that. But so for now, just call them indifference curves or level sets of a utility function. Any other questions? All right, so just looking forward, much later in the semester, we've already talked about how you combine goods into one utility function for an individual. Then we're going to have to think about, well, once we have multiple individuals, I have my preferences and you have yours. When we make policy, how do we combine my preferences with your preferences to make something that is going to be good for society as a whole? And so right now we're trading off among goods. Later on, we're going to have to trade off among people. In order to make it better for you, it's going to have to be worse for me. How do we deal with that? And we will use a lot of the same concepts from Pareto optimality to think about that. And yeah, Autumn, how much I'll sacrifice for the other good. Yes, think about the marginal rate of substitution, which is the slope of that line, is how much am I willing to sacrifice to gain the other good? And exactly how we interpret, you know, which good is which has to determine whether we put it on the horizontal axis or the vertical axis. But it is an exchange rate. How much am I willing to trade? If I didn't have dollars and cents and I was just bartering with you, how much would I be willing to barter to gain the thing that you have that I want? All right. Well, we're at time, so if there are any other questions, happy to have you guys ask those after. But I want to give you the attendance exercise. And so the attendance exercise is, I introduced a term, MRS, and I'll put this in the chat. And I want to know, what does the S stand for? So in this term, MRS, which is the slope of the slope at a point of the indifference curve, what does the S stand for? So the MR, we're marginal rate. So it's marginal rate of what? What does the S stand for? That's your second, I think it's second attendance exercise. So put that in there, hit submit, and that's all I've got for you today. So if you have any questions, you can stick around. If you're done with me, you can feel free to pop off, and I'll then end the meeting when we've kind of got a critical mass is left. So MRS, what does the S stand for? That's the last attendance question. You can fill that in at the Google form and hit submit, and then I'll tabulate attendance probably for both days this weekend. Great. Thanks for all your attention. Sorry we didn't do any breakout rooms or anything that exciting this time around. Just getting through some of the fundamentals right now.
Thank you so much.
It looks like people are popping off. So I am reaching for the end meeting. So if you have a question, feel free to bring it up. Otherwise, I will see you next week, and have a nice weekend. All right.